Okay, let's start. You are given a string, so hold the empty string. Apply one for operation till S and T are both empty. And remove a first letter, giving a robot appending to the string. We remove the last letter, writing on the paper. Okay, so you can move it to the last letter. Append to the last. So what should we do here? This will append the last. And so given a string, you will return it as because A should be smallest. So what is the idea? Sugar. Alright, what about if given a prefix of answers and the fire rate satisfy this value? This is the perfect sequence order. So, alright, so this problem, it's right, so because actually it's the right. Can get it. The empathy lab worked on the longest task given n per each, which is Leetcode, and given the two linear arrays where logs, and load out the ice test starts the moment right after the ice connects, and the task starting on time is zeros. Right, and log is the ID works on the X item. So works on the first item. Finish the item. What it means? It means return the ID that work the task with longest time. Alright, so n is 10 is unique ID, and right, so 0 to 10 and text 0 started by 0, and a string with 3 unique times to text 1, and a 5 with 2 unique times. So 2, and this is 4, and this is 6 units. And the text with the longest time is text 3 because it needs 6 in the 0 we have Alright, so ideas maintain time and just go through the pairs. ID or the size is greater than width. Actually, I think it's use the first logs 0 0 0. Okay, so if logs I minus logs I 0 is the time cost, right? So cost it's this. Cost is greater than time, it means ID is equal to logs I 0. Right? To example. Okay, so N I think is no use, right? Because wait, 26. What it means? Length is unsemplicity and ID. So for the first IDI is equal to 0 minus n minus 1. So it takes 6 minutes and at 1, right? And the 7. Text 1 is 6. So if ID is greater than the time, I forgot to update the time. Well, that's the problem. It's hard to think it. What is the idea? If you have a graphical smallest value, you always choose it. So we choose A. Otherwise it depends. So we can use a stake, right? So use a stake as we call it B. We remove the append to the T. Now T is B. And speedy. Remove the last layer. Yes, so actually I can use to check if it has smaller. What it means if B has smaller, so we hold it, has smaller, hold it, has smaller, hold it. A does not have smaller, so we pop out the string. That's the idea. And after that, we just try to reverse this whole string to the answers. The D, D, B. Right, so I have some idea. Build the array so that has smaller means after it has smaller, later it has a smaller later. Alright, so I want to build array as smaller. As and some cases and alright, so say this not has smaller, so it goes. And we do it reverse, so -1. If the values that means we have smaller. Alright, and let's just go through the string. If has more I, that means so this has more. Oh wait, so BAC here is that B in A is smaller, so A. And if or some idea is that smaller in smallest digit, right? So it's mean characters. So mean characters SI plus 1. Okay, so if this value is half back and this value is smaller than mean characters I simulated. So what is idea is build arrays after smallest later. Simulators just maintain it simulate. Alright, so let's train. Let's see what about. And so T size is not empty, so if should T will add about SI, and then we add this, and we know the mean later is not we add a string, and so idea is that if this value is smaller than mean later, otherwise we always push it T. And in the first, example, we always push a T, and alright, so just simulate it. Alright, passing matrix whose sum is divisible by k. So given the grids and indicators we want to reach, move down right, and the numbers of paths sum of element is divisible by k. So that means, right? So its idea is that we. Right, so this problem is simple. Actually, here is dp, number of ways divisible by k. Right, so we return 0 because we need divisible to 0. And what is the idea? So consider dp so that what is next is this modular from this value. So we will from this value alright, and actually I think it's just the add function. It's this value will add this value, add this, and empty. This is empty. Right, so division by 0. K cannot be 0, right? So K is 1, and division of 0, what means? Oh, we have here what? Alright, so there's some type of error, and this is who. The base case is that 0 and 0 we this empty string, and a plus 1 equal a. So from dp we update this 2 value here. Alright, the bottom-up solution. We can use a top-down approach, is that return sum should be 0. Wait. Actually, it's either this position is more correct, because this element will push into this element, and the dp last value is that after we add the value, we will either push it to the down or push it to the right. So this 2 will be the answer. Right? Right? So, right. So dp okay, because we don't ship it. So maybe this problem is more easier, but alright, so to be alright, so for problem A, this problem it's the problem it's yeah, because the living time is already increasing order, so this problem said that you want to find out the employee that work on the longest task. So so that I think the N is no use. It just tell you the employee's ID range, and the important thing is the log. The log is each person do on the ice task that takes some time, take the live time, and the live time is not it's not a working time. The working time should be for this item 5 minus 3, so it's 2. This task needs 2 units, so this task needs 4 units. This task needs 6 units, and this task tree is the longest, and employee is 1. And if there is a tie, return smallest ID. So actually, just linear one pass. You just compute the close up time and update the maximum, update the ID. If the maximum is the same, ID is the minimum value. Yeah, so that's a idea. And first problem, prefix equals or. No, prefix equals or is that it's like a prefix sum, right? So actually array it's equal to prefix I minus prefix I minus 1. You can easy to get it, and same as the equals or. Same as the equals or. So just if you know this, that's this problem is simple, right? And about this problem, I think this is a constructive algorithm problem, and needs some greedy strategy to do that. Actually, this problem, the large graphical smallest train is the greedy. So you have 2 operations: is either remove the first letter, or either remove the last letter of the string and add to the answer. So actually, it's like the 2 container, and you want to maintain this container smallest. You want to maintain a resource smallest, and what should we do here? Actually, important strategy is that if current letter have the smaller characters after len, that means this value must be hold. What it means hold? Hold is that we don't add we don't add to the answer. So we add to the t. Let's just see this example that can be more clear. So we maintained an array that is a minima letters, and for this letter is the minima letter is A in this position. Alright, so idea is that you build the minima letter, and for this example, the minima letter is going to be AAC. B is not smaller, so we add to T. We don't need to add to the answers because we have smaller letters after this. So we hold it. Now B is going to be in the T. And in the A, because this is the smaller than the probably the smallest, so we hold it to a string, right? But actually we can do update in the next, because we can do like this. We push. The strategy is that we push to the A, and we always compare the last letter. If the last letter, this should be do the first, because consider that if T is some string, and current letter is in this. If this X is smaller than Y, that means X should be pop out from T than this letter. So we always choose T first. So that's the main strategy, the greedy patterns here. So how do I make sure T is smaller? If T is smaller, it means that T is smaller than the T's letter. Last letter is smaller than the main letter from the back. So idea is that BA, right? And if A is smaller than the last letter of C, so A pop out this. B is smaller than last letter C, pop out that. And C, we push it, and after that we reverse the string because we put it from the back, so we add it as a reverse string, and add to the answer. So this is the idea. Alright, so if T doesn't have the size and S hold it to the T, and if T has a size, the T will consider to do earlier. So that's a main strategy here. Consider do earlier is just compare that if the string of the last character is smaller than the main character so far. That means we always can do T first. Yeah. So this item will be linear, and this is linear. Overall time complexity is linear. Space complexity is also be linear. So we're done. Alright. So I'm not sure I missed some pattern, but I think this strategy is the best strategy to figure out the smallest string, because you always put the T in first. That's the main idea about this problem. This problem is dp problem, and actually it's like you want to find out all the paths in the matrix that sum is divisible by k, and this item is common in Leetcode problems. The sum is divisible by k, you can calculate the modulo. If the modulo by k is 0, that means that they are divisible by k. And what is the idea? Consider we can from the string, and if what is the idea? Consider dp. We need a 3D dimension dp, and dp is that numbers of ways ending at starting from ij, and we shift the ij. So this last item will add to this item or this item. So that means the last answer is either in this position or this position. And we padding a additional dimension, let's say padding on 0, and the base case is empty, and the sum is empty, and position is empty, and it's an empty set. Numbers of ways 1, and we can add it. From this empty set, we add the value. This value will add this empty set. And now we can, from 2 directions, either j plus 1 or either I plus 1, that's the 2 directions, down or right. So, yeah, you get it. Also, you can do top-down. Top-down approach is more simple. It's either from top and either from right, and yeah, you can use divisible, right? So right, that's problem 4. Okay. Alright, so sync and done. Still took some time. Alright, so that's it.